In this video, we're going to talk about something called dimensional analysis. Dimensional analysis is a way that you can convert different units, whether it's in science, math, engineering. It really is applicable in a lot of areas of life. Dimensional analysis you may also hear sometimes referred to as the factor label method. Both of these mean the same thing, so factor label method. Um, Another name for these that you may hear is called a fence post problem. I've heard a couple of different ways of saying these, but if you hear fence post problems, factor label method, or dimensional analysis, all three of these basically mean the same thing for our purposes. So let's go ahead and take a look at a problem that we can use dimensional analysis to help us figure out. So if we have a question that goes, how many seconds are there in 23 weeks? We can definitely use dimensional analysis to help us with this. The first thing that we need to do is we need to go ahead and start with the information that we're given in the problem. It says 23 weeks, so we'll go ahead and start out and I'll write 23 weeks to start off with, and I'll go ahead and write a line, and I'll put this here. Okay, so basically, so I've got my 23 weeks already here, and what I'm doing, if you'll remember in math class, if I have something like 3 over 3, or if I have something like 5 over 5, or, whoops, that's not a 5, let's do this, 5. Okay, so if I have 5 over 5, these two are equal to 1. Or if I have something as far as units, if I have something like grams over grams, or if I have meters over meters, all those equal to 1 also, because whether they're numbers like the 3's or 5's, or whether they're units like grams or meters, whenever you have something over itself, mathematically that's equal to 1. So what we're going to do here, we know we're starting with weeks, but the unit that we want to go to are seconds. So I'm going to circle the seconds in a different color because we know that this is the ultimate unit that we want to end up with. So if I continue on with this, in order to cancel out weeks, I need to put weeks, the unit of weeks, in the bottom. Because just as we said here, if I have a numerator and the denominator, the top and the bottom number, if they are the same, they will cancel out to 1, and that's what I want to do here. I want to cancel out weeks because I ultimately want to end up with seconds. So I'll go ahead and put weeks in the bottom. But each one of these vertical areas of the factor label method, these are a conversion factor, meaning that these are equal. What I mean by that is, let's say if I had 4 quarters and I had $1. So even though I have the number 4 here and the number 1 here, I know that 4 is not equal to 1, but 4 quarters has the same value as $1. So that's what I'm doing here. I'm creating or figuring out the conversion factor to where these are going to be have the same value. So if I were to put something like this, say 1 week, I know that in 1 week there are 7 days. Now just like we've said down here, 7 and 1 are not equal numbers, but 7 days has the same value as 1 week. Okay, so as long as your vertical spaces they're equal in value, that's what we're going for. Okay, so now I know that my weeks will cancel out because I've got weeks on top here and I've got weeks on the bottom here. So I'm going to choose a different color and I'm going to go ahead and cancel out my weeks there. Okay, so we know that the week here cancels out with the week there. So let's go ahead and continue on. The unit that I'm left with is days, but I don't want days, I want seconds because we've circled that in the top. So let's continue on. To cancel out days, I have to put days in the bottom. Okay, so once again, I'm going to come up with another conversion factor. So I know that in 1 day, there are 24 hours. So once again, 24 is not equal to 1, but 24 hours has the same value as 1 day. So I'm going to go ahead and draw another line. And using a different color, again, I'm going to cancel out the days here. I'm left with hours. I don't want hours, I want seconds, so I've got to keep going. So I know I want to cancel out hours, so I'm going to say hours on the bottom. I know that in 1 hour there are 60 minutes. So I'm going to go ahead and extend this out a little bit. So coming back to canceling out, my hours here will cancel out with my hours here. 60 minutes is equivalent to 1 hour. I've got minutes. I don't want to stop at minutes. I want to go to seconds. So I'm going to continue on again. So I know to cancel out my minutes here, I have to put minutes on the bottom. I know that in 1 minute there are 60 seconds. So now you'll see the second or the minutes actually cancel out. So now the unit that I'm left with are seconds, and the unit that I wanted are seconds also. So once you get to this point, most of the work is actually done. So what you're going to do here is you just take everything on top and you multiply it together. So I'm going to take 23 times 7 times 24 times 60 times 60. And once I do that, I'm going to get a pretty big number. I actually come out to get 13,910,400. So now the next thing that you do after you multiply all of these numbers together, you can't forget about what's in the bottom. So I'm going to put another line under that. So here we don't really put anything in this first box, but if we want to put something there to make us feel better, we can put a 1, or you can just leave it blank. Whenever you see the blank, basically that's just 1. So here if we take 1 times 1 times 1 times 1 times 1, all of that is equal to 1. So now we know that 13,910,400 divided by 1 is still 19,910,400. So the final answer, and I'll do that in blue down at the bottom, because we know once we divide this, we get the same thing. So we'll say 13,910,400, and we can't forget our units. The units we were looking for were seconds. So I'm going to go ahead and put seconds on the end of this. So that is how you convert 23 weeks into seconds using the factor label method. Let's do one more problem. So the next problem that we're going to look at says how many pounds are in 58.2 milligrams. So I'm going to choose a different color here. So let's go ahead and start with what they've given me, which is 58.2 milligrams. So I'm going to say 58.2, put it out there, 0.2 milligrams. And go ahead and write my little fence post out. So 58.2. So once again, I want to cancel out milligrams, and the ultimate goal that I'm going for is pounds. That's what I'm looking for, pounds. So I've got to keep going until my units end in pounds. So I'm going to go ahead and put milligrams in the bottom because I know I want to cancel out my milligrams. I know that the prefix milli means 1,000th. So I know that there are 1,000 milligrams in 1 gram. Okay, this is just from your metric prefixes: kilo, hecta, deca, deci, centi, those. So we said milli means 1,000th. So 1 milligram is a 1,000th of a gram, or you can look at it kind of the other way around, that 1,000 milligrams is equal to 1 gram, and that's the one that we're using here. So I'll choose a different color. My milligrams cancel out. I'm left with grams, but I don't want grams. I want to go to pounds. So I know that I need to go ahead and cancel out my grams here and on the top. And in order to do that, I have to put grams on the bottom. So now I need another conversion factor. This is probably one you don't know off the top of your head. I mean, I actually had to go look it up too. But anyhow, 400 and let's see. Actually, let's get rid of that. Let's try this. So 453.59.59 grams is equal to 1 pound. That's how many grams is equal to 1 pound. But still, it works the same way, because I can take, now I know my grams are here, I can cancel grams out with grams on the bottom, and the unit that I'm left with is pound. And that's convenient because that's the unit that I was wanting to get to anyhow. So once you get to this point, the hard work is done. Setting it up is the hard work. The next part is just punching in the calculator and computing. So once again, once you get to this point, you get the unit you want. You take 58.2 multiplied by 1 multiplied by 1, and that's going to give you 58.2. 58.2. Alright, so there's my decimal. And then I'm going to divide that by everything on the bottom. I know that 1,000 times 453.59 is equal to 453,590. So now what I have to do is I got to take 58.2 divided by 453,590, or 453,590. And once I work that out, I actually get this really small number that's 0.0000128. If I wanted to put this number in scientific notation, because it's actually kind of small, I would say 1.28, and I'll count decimals if I'm starting here, which is my 1.28, and I count 1, 2, 3, 4. So I'm going to say times 10 to the negative fourth, because I'm moving the decimal to the left. If I were moving the decimal to the right, it would be positive 4, and I would have a really big number. But because I'm moving the decimal 1, 2, 3, 4 to the left, it's negative, which gives me a really small number. And my units are pounds, so let's not forget the units on pounds. So the answer is 1.28 times 10 to the negative fourth pounds. And this answer makes sense because milligrams are a very small unit of mass. And if I don't have very many of them to begin with, my answer in pounds should be a really small number. And we see that the answer indeed is a really small number. It's 1.28 times 10 to the negative fourth pounds.